Yeah, everybody, thanks for joining us today. We're really excited about this presentation, and certainly it's a timely topic. As this is a little bit of a different forum for us, we are very excited to have Anita here. We do have, however, a little bit of a time difference, and for this virtual coffee, it definitely made sense to try out kind of a pre-recorded format. So we're very excited to have Anita join us today. And per our typical virtual coffee forum, we hope to hear a lot of great questions. We've already had an abundance of pre-submitted questions, really good questions. So we will be addressing those on a priority basis here throughout our presentation. And of course, if something comes up during the presentation, you can submit that now. Or please feel free to follow up by email, and we'll make sure to reach out and address those. So I hope everybody has their coffee or whatever beverage of choice. I know it might be a little late for you, Anita, to have coffee. But yeah, so why don't I go ahead and we'll get into the details of introducing Anita, our guest. And first, though, I'll hand it over to my colleague, Rick Serber. He's just going to kind of get us primed on the topic, talk a little bit about why all of the buzz, what's happening right now before we talk to Anita a little bit and go through her presentation that gets into the weeds a little bit. So I'll hand it over to you, Rick, if you want to kind of get us all excited and hyped up about what's going on and why our topic is so relevant for today.
Absolutely, thanks, Jen. So we're going to get into the details about the different types of AI and what fuels these different uses between natural language, generative, machine learning, and a bunch of others. And so I'm just going to introduce some of the applications here to kind of frame this. Crawlers, these are likely familiar to many RIM practitioners already, so I use this as an example first. AI-assisted auto-classification, essentially, data that's not already categorized, including some pain point areas for clients like unstructured network shares. Lots of developments going on there fueled by AI and becoming more efficient based on AI. IoT, Internet of Things. An example here, Google Maps on your car GPS, for example. AI's got broad implications to enhance some of this. For example, Google Maps is working on an immersive view route planner where you select your route and AI stitches together all of the street view photos to essentially give you a view of your route as you take it. And so that's all in the works, but I mean, they seem pretty confident that that's gonna be something in the near future. Really cool. Self-driving vehicles, another example of how AI is helping the effort to refine this and make it even better. And then, the biggest one that we know about is ChatGPT, Bing, these generative language services that are very popular right now. And we included just some statistics right there, over 100 million users, 1.6 billion visits in June alone. I think the thing that is impressing most people is the very human-like interaction that these generative language services are providing. So just to give a quick overview of some of the things that we're talking about, and we're really talking about the technology and the knowledge behind a lot of this stuff. So yeah, Jen, back to you on the roadmap.
Thanks for that, Rick. So just a kind of a quick roadmap to get everybody acquainted with the presentation before we go into our introductions in detail. We'll get into detail. Anita's going to walk us through more about what is AI, including the AI components and big data. And then she's also going to share her kind of boots on the ground experience, what she's seeing through the course of her career, how, for example, health sciences is leveraging AI and big data for innovation and development. And then also we're going to get into some of the ethical regulatory considerations, and Zasio will be kind of jumping in on a few of those items, as well as the implications for RIM. So just an overview, but why don't we go ahead and get to our introduction here. I know, so just a little bit of background on this. I talked to Anita at a presentation last year. I attended her presentation on this matter, and as everything really kind of ramped up in the area of AI and ChatGPT this year, I thought back and I thought, wow, it would be really great if we could have Anita bring that presentation to a virtual coffee, because I thought it was so great. I thought it was a really great overview. It doesn't matter kind of what your background is. It's really, for me, it was set forth in a really straightforward and concise manner for the layman's terms, kind of understanding AI and getting that background. And then, of course, her experience in the health sciences industry, kind of as a case study, was really brought it to light for me. So I was so glad when I reached out. Anita was so gracious. Even though she just recently retired, she did agree to join us, and we promised her we wouldn't make her do too much of the heavy lifting on this. But really, this is the majority of this is her presentation. Zasio has just a couple of slides that we've added, and those are marked by the purple flags in the upper left-hand corner, and we'll be kind of interjecting a few times just to present on those. But really, this is mostly Anita's presentation. So we're so glad that she agreed to join us and get into the details. I want Anita to go over her background, because I do think it's really interesting what her journey looks like. I think every one of our presenters, it always looks a little bit different, and certainly Anita's is unique in its own right, and I would like to have her share that with you. So Anita, thanks again so much for joining us today, and I will kind of hand it over to you, and if you wouldn't mind just kind of walking the audience through your experience, your journey, and how you kind of ended up where you did in your career and where you are today.
Well, thank you, Jennifer, Rick, and Jerry for having me here today, and also to be able to present a bit what my way into RIM and information governance was. It wasn't really what I wanted to do. Actually, I wanted to study sports. But then my parents told me in the early 80s, well, sports, why don't you do something where you can actually probably get a good job as a baby boomer? So I took a degree in library science in Frankfurt, and I apologize that I'm not as fluent as our Boise, Idaho's colleagues here with the English, so please bear with me if probably some of the things are not as accurate. And I worked then as a librarian also in Germany for 5 years, and I decided, no, it's not what I want to do for the rest of my life, but also triggered by the fact that computers entered heavily into the library world at that point of stage. I was still working with stacking cards and feeding cards into the mainframe computers. So I signed up for a master program in information science and technique, so it was IT information science combination at the University of Constance, also in Germany. That was actually funny because that was in the mid-late 80s now, and that was the first contact with AI I had, because at that point of time, expert systems were the hype of the day. So I did also my master's thesis on semantic networks for expert systems. Apologize for the typo there. The studies also brought me then to the US, where not only I was able to join OCLC, those people from you also knowledgeable about library science probably have heard of it. It's the biggest library database in the world at that point of time, and I still think it is. I also worked with Chemical Abstract Service in Columbus, Ohio, and worked there in OCLC on an expert system for cataloging, so back in library. I brought back my husband from there, back to Germany, where I started to run a project on open systems interconnections, again in the library context, because it was about reconnecting research networks, libraries, and booksellers. Also worked on the ISO search and retrieve protocols at that point of time. So still a little bit connected with the library field. And Then I joined 1991 because a lot of my Constance study colleagues worked in Switzerland, and they said, well, why don't you come to Switzerland? It's great here, a lot of mountains, a lot of things to do, good salary, so why don't you join in there? And I took a job as a head of regulatory archives. No idea what archives were at that point of time. Over the years, I moved into various steps in the company, various jobs in the companies throughout IT, clinical science, regulatory affairs, quality department, and finally legal. I had the chance also to continue my studies there in pharmaceutical development, so I did another degree there. Which I still think is always important for records and information management, to know what the business is about. If you just know RIM and IT, I think it's very difficult. It's better to get the seat on the famous table if you know what the business is talking about and where there are pain points are, where you can actually contribute as a RIM information governance specialist. My last years, well, last decades, I should say, I started the company-wide records management program because the company itself has a very decentralized culture, a lot of individual businesses. So in the US, for example, Roche is known through its Genentech pharma part, which covers the US and North America, Canada. So in this regard, it's very difficult to do something from the top down and tell them, so this is now the processes and this is what you need to do. Everybody was doing their own bits and pieces, and nobody really knew where the data truly resided that's needed to do a submission to the health authority. In this regard, I think we achieved a lot over the years that we set up together with my team, the company-wide records management program that we ultimately then turned into a full-blown information governance program, because we got an alignment with the other crucial functions, so especially data privacy, IT security, business quality, data science, who are of course also interested to know now where the data is in the company, to use it for these various purposes that we are talking about today in terms of big data, reuse of data. And in this part, of course, records and information management is not just the pure people boxing up the paper files, but it's really becoming a crucial success factor, in my belief, that you really need to make sure that you can find your role in the organization to contribute to that. I also participate and still participate in various industry groups, which I also think is very important. And I know you do that by, for example, attending this coffee talk, this virtual coffee talk, that you look out for information. How are other companies doing that? What's going on in my industry area, in my vertical, in regards of information governance, information management. And I just list a few of those that I participated and also organized and led over the years. So, but this was a little bit why I'm sitting here. And now comes the point of today's focus. What is artificial intelligence? I have compiled a few definitions that you can easily find on the internet. The first one was actually done in 1955, and it was very much still focusing on the science technology of making intelligent machines. So intelligence already occurs here. More recently, the definitions, and I'm not going through all of them, I think you can read for yourself, is that here in the newer definitions, the problem solving, decision-making capabilities, the ability to mimic a human more or less, it becomes more in the focus of the definitions. And I think that's, for us as human beings, on the one hand side, intriguing, but also, of course, the challenging and scary part. Now, how do we actually identify an AI system? And you heard through the introduction here that Rick gave, it's very much difficult nowadays with the capabilities of ChatGPT. You've seen in the news that universities, some states, also in the US, ban ChatGPT for certain purposes in schools. For here in Europe, for example, there's a discussion that there's no written exams anymore, but only verbal exams in the future. So how do we actually identify if it's a human that has created that text, or was it a machine? The famous Turing test, this is going back to Alan Turing from the UK. You have probably seen the Hollywood movie, The Imitation Game. It's been a few years, I think 10 years probably, or even longer. The objective of that test, it defined already in 1950, so more than 70 years ago now, was to see if it's a person or a machine answering. At that point of time, think about it, these big mainframe computers that filled up huge warehouses and computational centers being fed more or less having less computing power than your smartwatch. That was already a discussion at that point of time. The only recently, so in the last few years, was it that a computer system passed that test. Lambda, the system that Google Chat and ChatGPT were among the first ones to pass those. I think the actual first one was really a Russian system, but I'm not sure about the name now. So when we talk about artificial intelligence, we have various areas. We can more or less group the areas involved in what artificial intelligence is, so the components, to the foundation elements, and that's the ones that we will be talking about mainly. Here is machine learning, big data, natural language processing, and neural networks. We have then the application area, so the expert systems that I mentioned, the ChatGPTs, etc., the speech to text, text to speech, robotics, vision. You already heard a few examples there from Rick. And a special element is the cognitive computing. I won't go into that one. What we will be mainly looking into, what is actually the foundation elements and what are the application areas in terms of how it affects us now, my examples of health sciences. Key components of artificial intelligence is, as you said, the knowledge acquisition. I need to have input via big data. That can be images, unstructured, structured data, films, you name it, everything that's storable. You do have, same as with normal computing, you have the programming and algorithms, and the machine learning, and especially then the deep learning via neural networks. It's not necessarily all in this sequence, but these are more or less the three key components that contribute to the generation of an AI system. Let's take a look at the knowledge acquisition. As I mentioned, that can be anything, images, text, health data, fitness trackers, your CCTV, surveillance cameras, anything can be used. And I think this is always where we need to make sure what is it that I contribute as a consumer, as a private person, as a professional person, with my family, and the discussions we have about our children being aware about how to use social media in a meaningful way, because of course that can all be analyzed, and we can become more or less, people know the computers, or the people behind those computers know more about us than ourselves lately. And you all read these examples as well, where potentially then, I think this funny joke, and I don't get it in details, where ultimately then somebody got a bottle of milk bottles and Pampers sent to, because somebody already knew that the wife was pregnant. Big data. So what is big data in our general public understanding? We pay with our data, so the data is the currency. Read with commercials or pay for a licensing service. So typically, of course, if you just want to use an app once in a while, you say, okay, read with advertisement. And then, of course, your data is collected in, and of course, the cookies or whatever, even if you have a license, is also collected. Tech companies are the black holes absorbing our data. So just, you know, the Googles, Amazon, Facebooks, you name them, ultimately collect whatever they want to make sure that they target their products to our needs. But what exactly is big data now, apart from this common understanding and this what makes us a little bit uncomfortable? So there are three important components when it comes to what constitutes big data. It's what they call the 3 V's, the variety, the volume, and the velocity, that contribute to the importance of how you build up big data stores. So it's the exploration and combination of always new and growing data sources in an unbelievable fast time frame. Big data is what we call the nurturing element, the food of the IE applications. I should have mentioned, it wasn't this presentation originally. I generated that for a senior citizens council here in my hometown. So that's why some of the phrases here may ultimately to you as pretty much IT aware and sensitive people may sound a little bit funny, but then of course I adapted it a bit more to the needs of the audience such as you and the ones that I had at the presentation last year that Jennifer mentioned. The training of the system is based on new and increasing data and to enhance further insights. So ultimately that the neural networks that we're going to come to later can extract and learn from always growing new and available insights. So like the GIGO, in fact, garbage in, garbage out, the more better up to date and specific, but also more diverse the data, the better the results. Also the GIGO, in fact, as I mentioned, garbage in, garbage out still is, of course, when we come to biases in data, is always still also a challenge. So the understanding and the selection of the initial training data is very key. That's where the GIGO effect comes in, because that can also, even if the system is smart in learning, if the baseline is wrong, it takes a longer time to ultimately come up to speed with good results. Sorry. So the next part that we look at the algorithms. So again, of course, in order the data is one thing, but you need to have then an application that can do something with the data, i.e. learn. So algorithms, in fact, are structured programming, are coded instructions generated by programmers, so structures, libraries. The objective of the RE algorithm, in difference to the structured programming, is the self-optimization of the algorithm, so the machine learning and later on the deep learning specifically. Ultimately, the programmer should not get too much involved anymore later on. And we come to that maybe when we look at the regulations here that are coming up and the responsibilities. We also received some questions in this regard. In principle, many languages can be used for IE applications, especially for the API programming, so the interface programming. Typically nowadays, Python is the language of choice. In data sciences, R, as a statistical analysis language, is frequently used. So those are, when you hear those terms, those are at least today, 2023, the languages of choice. Now, what is now machine learning and deep learning specifically? So let's take a look first at machine learning. The usage of the algorithm to analyze and learn from an increasing amount of data for better decision taking over time is called machine learning. Here I give an example. I have here a cat and a dog, or specifically in the other order here, the dog and the cat. So what does it mean? In machine learning, you have to feed them, you have to tell them, okay, a cat, in order for you to recognize, let's say, images of a cat, they typically look less interested, a little bit, it's me, the queen, and it purrs. If you have voice language recordings, it's got long beard hair, and the dog, of course, you also know the features. You feed in the features, and then the system learns to apply those features. Deep learning is a special category of machine learning, and it uses a multi-layered, more powerful algorithm, self-improving algorithm to construct neural networks. It's test loop programming to adapt the underlying models and the adaptation to enhance the patterns and the outlier recognition. So it's basically, it learns, it trains itself, it enhances itself, it improves itself. So the self-improving models, the program attribute, so you just feed them some pictures with some very initial key features, and it identifies more and more to identify the animal. So it learns itself from the data. You don't have to feed anything potentially to figure out that's a cat and that's a dog. So let's take a look at those neural networks. You see the graphic here. You have the input layer here on the left, the output layer on the right, and in the middle is the black hole, the hidden layers. So layers, because is an iterative process, it goes back and forth. What it tries to do, it imitates the human brain cell process. You know that we also have not necessarily a sequential, but a back and forth and a very much interconnected way our synapses work in the brain cells. The data is only visible, so what I input, what I feed from the big data, what's available on the internet or whatever. Nowadays we don't even know that because the scope is so big, and the output layers. The hidden layers are black holes. So every neuron here is assigned an initial weight, and it assigns the perceptrons to it assigns a weight to the inserted data, and then the results of the calculations, very complicated calculations back and forth, more or less then assign different weights depending on the importance and the correct answers to that vary. So the importance to the question asked or to the problem that is trying to be resolved here. The adjustment goes back and forth through so-called propagation, or as we call it, learning, and the calculation of the final result is then done and presented to the output layer with the highest calculated values becoming the imported answer here. I will run a little bit faster here now. I'm going to give some examples how artificial intelligence is used, for example, in healthcare. We have diagnostic images, diagnostics and image analysis, for example, in breast cancer screening since a long time. We have out of this diagnostics then decision taking. So for example, a tumor board decision software suggesting treatment options based on the individual patient results, and combination with big data, medical papers, study results, etc. We have assisted robotic surgery and virtual nursing assistants, social robots, electronic health records management, you name it. Clinical development, for example, the study of a new clinical trial uses artificial intelligence. Now you have site identification. So what's the best sites, hospitals that we can use for good patient and fast patient recruitment? The monitoring of those sites, triggers, alerts, when something may potentially go out of protocol or go wrong. truck safety monitoring. Are there any signals that show that there are issues with the truck or with that patient? And also the health authorities, of course, now accepting, instead of full-blown new clinical trials, real-world data, real-world evidence as a surrogate marker, so to speak. Ethical and regulatory impact is our second last chapter to look into. The biggest question here, and that comes also into the ethical question we received, what do we do to have confidence that, let's say, a business is using artificial intelligence in a meaningful way? For me, it's always coming back to how do I avoid bias, how am I transparent with my customers, how I use artificial intelligence. We will see later also that there are special regulations in place already that demand very much a sequential approach, and how you treat bias and artificial intelligence applications. Bias occurs in data selection as well as in the programming, and also the view of the society determines the available data. So the existing data, always keep that in mind, always reflects where we are now and not necessarily where we as a society want to be. And I'll show you some example later. The view of the programmer determines the algorithms. What kind of weights do I put onto the data, and so on. So how can we avoid this bias? I think is the big topic here is awareness. We have to be aware in every part of the process that there may be bias, and maybe have controls, another person reviewing, and that's where the regulations come in, and also make sure that it's clear where bias can occur and where programs could be not going in the direction that we want them to go to. So let's take a look into the bias in data. So if you look for the images CEO in Google, what do you get? Typically the Caucasian male. What do you get when you search for office assistant? Still, you get the young female. So, and I think this is a good example where the bias in data, is that really what we want as an output? And an example here shows, for example, where Amazon already a few years back ran into issues when they started a project in the HR department in 2014. And what happened was to filter potential candidates instead of having human beings, using an algorithm to see is this person a viable candidate for that job before he is interviewed or she is interviewed. The project stopped in 2018 because female candidates were definitely not considered to the level that they applied, because the RE drew decisions based on the former hiring dossiers, and at that point of time, for some of the jobs, very clearly in the past, it was typically a male job incumbent and not yet a female, especially for the higher paid, higher ranking jobs. So in health data, we have the same issue. We have to be aware that medical results often come from Caucasian males. So what, in consequence, two cases here, skin cancer in African Americans were usually in the image diagnosis not so easily detected because the data was simply not there. But it also generated false results, or it can generate false results, because non-Caucasians, as an example, were seen as healthier, as they generate less costs with the health system. So it's a pretty stupid mistake. The algorithm was basically just taking data that looked at healthcare costs as the proxy for health needs, and we all know that it's actually usually the other way around. So what I want to say quickly to big data and data protection, there are two different paradigms. Big data is the more the better, the maximization principle. I want to have as much volume. The data protection is the less the better, the minimization. Now they are not necessarily now exclusive because, and I'm coming here from the EU, the GDPR, the General Data Protection Regulation, does not prohibit the collection of personal data as long as there is legitimate use, consent, and the deletion after end of legitimate use, respectively, the anonymization, that also counts as a deletion. My last slide here so far is the attempts to regulate the AI in the EU, and it comes back to some of the questions that are what constitute records, what will need to be done from an ethical perspective. I think we will see, and Jennifer and Rick will come with some examples from other parts, especially the US and China. We will see more liability regulation coming up. So some of it is already in place in the EU, for example, for the medical devices. And it's what I would suggest. As I said, from the healthcare industry, if you make yourself familiar with the regulations that are already in existence in the finance industry, I'm sure there's already something being said about artificial intelligence for stock trading and so on. We will have a new, similar to the GDPR, a new E-Act is under review right now, a release expected in 2026 as a new regulation for the EU, which defines then risk categories and where there clearly, when it comes to the ethical approach, some that are unacceptable and that will have huge penalties. So if you have cognitive behavior manipulation, social scoring, and so on. You have another category then as high risks, safety regulations, critical infrastructure, law enforcement, etc. And then you have things like ChatGPT, transparency requirements associated with that, and limited risk RE that could be used then without major regulations or liabilities that you have to be afraid of. As I said, there will be a strong penalty and the governance structure will be most likely similar to the GDPR. With that, I hand over now back to Zasio. So if you want to talk quickly about the North American regulations.
Oops. Thanks, Anita. I appreciate that. We're happy to kind of introduce what we're seeing. And we just categorize this as North America. Coincidentally, we have Canada that has it's pretty recent, introduced the Artificial Intelligence and Data Act, the AIDI, that is yet to be adopted. But I think what we're definitely seeing is kind of a pattern across some of the proposed regulations. So similar to some of what Anita covered with the EU, proposed framework, we're also seeing an emphasis on looking at what they call kind of high impact systems. So it is kind of that a risk analysis and identifying systems that might pose higher risks. For Canada, under the AIDA, there's some certain criteria to look at in determining whether a system might be, an AI system might be considered high risk. That includes like risk to health and safety, severity of potential harms, how widely is it used, and ability for individuals to opt out of the system. So different considerations, and really, similar the ideas to kind of guide, require some sort of governance oversight, assessment of the system, and ongoing monitoring for those systems that are produced and adopted. The US is a little bit, I use the term aspirational, so self-regulation. I think there's a lot of trust here, and I think what we're seeing is maybe some different approaches, maybe the US being a little bit more hands-off in their approach at this point in time. And what we're seeing a lot of this oversight being driven by currently is some of the consumer enforcement litigation things that are going up against things that are already available in the private sector. We have this case, for example, and this is actually just came out, this decision, August, so this month, but it was a case that was brought forth by the Equal Employment Opportunity Commission, so a U.S. Agency, against iTutor Group. And this was a software that was available and is available. It's a recruitment software. And ultimately, based on the learning and the algorithms that were developed in that software, it was basically filtering out women under the age or over the age of 55, I should say, and men who were 60 or older. So going back to that bias that we're seeing, and is conflict really with laws that are already in place. So that's discriminatory. The EEOC brought forth that action, and they were actually ordered to pay $365,000 in restitution directly to 200 job applicants who were discriminated against based on that application. So just an example of a consumer litigation that's likely going to continue, litigation action that's likely going to continue to drive some of these changes, laws. Recently, July, 7 major AI tech companies agreed to some voluntary commitments. And so, going to some of these, the ethical considerations in developing AI and the effect of AI on individuals and society. Part of those commitments were, going to kind of the risk assessment and making sure, that any sort of AI technology that's made broadly available meets a certain, criteria for its risks. But also part of the commitments is transparency for consumers. So consumers know what they're ingesting, and like there's talks of watermarks, so people know what's a product of AI. That's part of these voluntary commitments. Again, so no, there's no fines or penalties for non-compliance. Again, kind of aspirational in nature, but some of these were just very much kind of, again, on that, let's set an ethical tone for this. So these major AI tech companies have agreed to prioritize research on societal risks of AI, including discrimination and privacy. They've also promised to develop AI with the goal of helping to mitigate societal challenges such as climate change and disease. So we'll see how all of that goes. But so I think that was kind of interesting. The government has set forth, the US government has set forth this blueprint for an AI Bill of Rights. It's based on these 5 pillars that we mentioned here, trying to kind of guarantee some consumer rights in the context of AI. And so safe and effective systems, making sure that there's algorithmic discrimination protections, data privacy. Again, there's data privacy is a very common theme that we're seeing throughout all of this. It's almost, it's very difficult, I think, to separate AI and data privacy. Notice and explanation, providing individuals notice of the types of AI that they might be subjecting themselves to or utilizing. Also human alternatives. So that's kind of an interesting idea there, whether AI really is the best alternatives, or whether in certain circumstances humans should be the ones performing certain tasks. So again, there's ethical considerations there. And then, as is the case, we often see with the US, there's a kind of a patchwork of laws that are coming up. So the states are kind of leading the way as far as actually promulgating, publishing laws on the books. So as far as codified legislation, currently there are around 24 states that have enacted or proposed legislation, including we just had New York City put a law on their books that came into force this year, prohibiting AI bias in hiring, which seems to be a theme that we're seeing as far as some of the negative implications for AI and how it's being used currently. We go to our next slide. Rather than attempts to regulate, we're going to call this regulating AI. China, I think we'd be remiss if we didn't talk about China, because They have really been ahead of the game, I think, and initially what we see here is some of their policy initiatives going back, beginning in 2015, made in China. The idea of developing AI to apply it to production technologies. And so we see China really recognizing that, the potential for AI, how can we promote this and how can we ultimately harness this? So I think there's a little bit of a idea that, yes, we want to promote innovation. And part of this, I think, goes to kind of the promoting the industrial and socio-economic aspect of this. How can we harness this? How can we leverage this? And then going into our next point here, if we can go, and now into the regulations. So a little bit of a top-down approach, and so a patchwork of laws that we've seen here, but ultimately, so we have our data security law that's already in place. Of course, we had the PIPL that recently came into play, and then also the administrative provisions on recommendation algorithms in internet-based information systems. That's a mouthful there. And most recently, I think 100% on point with its aims in regulating AI are the draft measures for the generative or artificial intelligence services. So that's really going towards a lot of these AI products that Rick kind of introduced us to, these fast and furious products that are coming out that are really consumer accessible, and making sure that they get the regulations in place for that. And it does go so far as to require, like, firms, they call firms, but essentially companies, they have to get a license to be able to provide generative AI services. So less of a hands-off approach and more just making sure that they have a say in what is generally developed and made available to the consumers. So they have a provision within the measures of generative AI, also requiring, that AI providers have to uphold the integrity of the state power, refrain from inciting secession, safeguard for national unity, preserve economic and social order. So you do see that element where I think they're really trying to kind of harness, they recognize potential risks, the power of AI. So how do we innovate this, but also kind of control it at the same time? So China definitely kind of unique in their approach, and they've been at it for a few years. So I wanted to make sure that we introduced China.
May I just make a comment out of practice experience? As for those of you familiar with the data security law, it's of course very difficult to understand what's really behind and how you ultimately can comply, especially as a multinational corporation. So it's probably what we can expect, that some of the regulation is for really putting it into the works. It's going to be very difficult because again, it's more the interest, of course, of the state of China, of the nation of China, to have the controls here. It's a little bit a different approach than potentially in other countries.
Thanks. I think that's a really great point, Anita. And I definitely think that's what we see here with these different laws. One thing I wanted to mention too is we had a question come in, and this individual asked, are there any AI regulations that relate to RIM? Any specific requirements related to retention periods, including data privacy requirements? And I just wanted to point out that in some of these, these frameworks, these proposed regulations, we are seeing mandated kind of record keeping requirements. And so to kind of summarize that, definitely within the AI framework, we also see that in the AIDI for Canada, but ensuring that there's kind of records that are generated and maintained surrounding these different assessments of the AI systems to make sure and determine that that risk profile, and whether you know, what category of risk to assign, and whether it would be feasible under the laws to create that AI and to distribute it to consumers. Also, we're seeing like record keeping requirements under how personal data is being anonymized. That's under the AIDA, and then also evidence of like kind of ongoing monitoring. Article 12 under the EU framework talks about record keeping in with regards to the logging capabilities of systems, and using those logs that are generated to identify incidents, and also kind of conduct ongoing monitoring of those systems. So I wanted to make sure I address that because that's something that specifically has come up in some of these laws.
And again, as we are coming now to the last section in the last minutes here now for the RIM professionals, again, my advice is really to look into the specific, like in our case, the health sciences, of course, the FDA, the MHRA, the SFDA, whatever the EMA in Europe, they all come up with certain requirements now when it comes to using artificial intelligence, and that's what I assume will also be in the other sectors and the other industry verticals, where you can see, especially in the regulated ones, with very clear definitions, also what is expected, maybe not so clear, but where you can deduct what should be kept, as Jennifer was just mentioning, log files, who had access, who was generating that, when was the system updated, what kind of data was inserted, what were the data pools. So let's take a look at the last section here, the benefits that we see for RIM professionals. Some of that was already mentioned before in the beginning: auto classification, rot detection when you go network crawlers, metadata assignment, the chatbots to help us with RIM systems being rolled out, the training to our customers and clients. Legal hold assignments certainly is also a big topic, of course, in the US legislation, but also things like format obsolescence alerts that could all be coming up through AI technology. I have to confess, I'm not the expert right now what's already being offered on the market, but I guess here with Zasio, you will have a company that's also looking into these things. What to store as record, that's where we already mentioned. We got a few questions. There's not the simple this and that answer. So there's not a list that we can give. So as I said, what to store as record, for example, again, my EU view deletion plans are, for example, very important for big data collections. What do you have? What have you used? Do you have log files? But again, the GDPR, you cannot just keep all the data, especially if it's not anonymized and pseudonymized. So if you work with keys, you can still recreate the personal data, that's not considered as a deletion. What about underlying big data pools used for the conclusions? If, for example, in clinical trials, so the standards or formats we need to be defined. Is that in which format do health authorities or regulators or whatever want to see and want to perform inspections, want to have submissions? That's still in the making, but I think we will see a lot of things coming up over the next years. And how do we archive and preserve our algorithms? So the EU regulation, we talked about it, Jennifer mentioned it also in the other upcoming regulations. So the EU regulation proposes 10 years for underlying technical and transparency documentations, or also for algorithms. But what it all will include and so on, that's of course still something, and what the expectations are in case of an inspection, that's what the future will show. What's also on the horizon is a rolling certification process. So you will not just go as now, you will go out and then you get it approved and then you're done. And then it's just a question of liability and consumer law. I think there will be more of rolling certification processes for these self-improving systems. on the horizon, we will see totally different changes on how our regulations will deal with this sort of data. With that, I hand over back to Jennifer or whoever's taking that.
Yeah, thanks, Anita. So these are just some considerations that we went through and kind of tracked for you guys and wanted to share. Reliability of information as a RIM consideration. You guys probably heard about it. We're tight on time, so I'll keep it short, but this is a blind reliance horror story. A New York lawyer was sanctioned for generating a brief from ChatGPT. Included incorrect and outdated case citations. The judge made an example of him. He's been sanctioned. But from a RIM professional's perspective, it highlights, records reliability, understanding how records are being generated and which involve a component of AI, ensuring that where AI is involved, that records generation is the tool used, but that the data is good and the output is fact-checked. It also emphasizes kind of properly training employees about how to use AI, which we're going to talk about on the next slide. Now, whether it's within the purview of like records managers at your organization to perform this type of oversight kind of depends on how your organization's organized. We had a pre-submitted question asked whether we're seeing a shift in the reporting structure of RIM professionals. My answer is yes. I think the trend for many clients is to shift RIM under compliance, recognizing that it's one of those processes that's designed to cut across and through silos to be impactful to a lot of departments. And so these companies are finding that they can reinforce how significantly RIM initiatives can help reduce risk with things like helping ensure many of the different things. AI records reliability through process development and oversight is one example. It's a great way to strengthen kind of the RIM program overall and help cut risk and help with compliance. But AI's role will also vary based on industry and values. We had another pre-submitted about an educational organization ask, how do learning institutions maintain interest in learning with this technology? I think it's a great question. Major technological developments like computers, the internet, email, I think they're analogous to the impacts that AI has potential to make. While some roles may already be becoming obsolete based on this technology, based on those prior technological enhancements, I think others will develop based on the technology. So I would answer by saying that we just have to find a way to balance this new technology to enhance our processes while maintaining integrity and reliability of the advances that it brings. So leaving that kind of intentionally vague and high level. But another thing, Jen mentioned that the notice to AI users. Here are some notice things that may not be obvious. As far as proprietary goes, Samsung just revealed that its developers entered its source code into ChatGPT to assist in development recently. They described it as a source code leak, recognizing that the information is now saved to ChatGPT servers and that they don't have any way to recover it to ensure its deletion. So they've subsequently banned use of AI generative language services by employees. So be careful what you're entering into these things. Confidentiality, similarly, Google Translate, be careful not to translate confidential information using Google Translate for the same reasons. That information that gets entered into it is now on Google's internal servers and could be part of their big data pools like Anita talked about. Not ideal treatment for confidential or sensitive information, and probably runs afoul of your organization's policies about the treatment of that information. There's some copyright.
Sorry if I may quickly step in.
Go ahead, Anita.
The translate is even if you have a corporate, the business, it's not covered by that. So it's really fully going into the database, into public.
Exactly. From a copyright perspective, there are a bunch of authors that are upset because essentially some of these generative language services have taken their books, they've entered the books into them, and now they're spitting out kind of summaries, which, derivative and summaries, and the copyright impacts on that are definitely going to have legal applications, and we'll see what happens. The final point was biases. It requires, kind of human review to align with these values. Anita covered biases really well from a garbage in, garbage out perspective, but just being aware of that and working, you know, to ensure that the garbage doesn't make its way in, and that there's a review to make sure the garbage hasn't found its way out of into the output. It really reinforces that emphasis on ensuring that records generated using AI are reliable. And so, you know, finally on this, staying one step ahead, I don't think we have time to go through all of these. We're already at the hour, but just really staying informed and making sure our core RIM priorities are considered under AI. You know, reconsidering all of these things like, you know, your policies, procedures, guidelines, your training, your change management, all of that, and making sure that it's been kind of considered and that AI has been considerate of them in an analogous way that, you know, email has caused us to re-question the way that our policies, procedures, guidelines, processes work, is really the best way to kind of be proactive from a records management perspective and make sure that, you know, we're including AI and, you know, to the extent that your organization is allowing it, making sure that some of these horror stories don't find their way into your organizations.
Yeah, and I think one of the last questions was what can companies do to not to lose the trust of their customers? I think, as you say, probably an ethical charter, or maybe worthwhile being part of enforcing the compliance, making sure that IE cannot be misused in the organization. With maybe even criminal energy, that's very important to keep the trust and the reputation of your company.
Yeah.
Yeah, so the last slide before we say goodbye here is it's not all bad. This is where I ran into, I'm not sure if it's still in place. And if you ever go back to Vegas, or those people who have been recently in Vegas, at least I saw that prior to the COVID pandemic, when I was in Vegas last time, the robot that mixes you the cocktails, perfect for me, an IE application that I'd like to use.
I love this. This one,
Yeah.
this stuck in my mind after your presentation. I'm glad you shared this, Anita. Well, great. We just have a couple more slides to go through, just a matter of business to kind of wrap up. A little bit about Zasio, that'll be included in the slide deck. We don't anticipate going through this, but our next slide, we will have another session. It will be in October, the exact date, time, TBD, but it will be a privacy year-in review with kind of a bird's eye view, all of the new stuff that's come through, India's new law, a lot of the stuff that's come up with the state. So we will keep you in the loop and provide those details soon, but we hope to see you then. So thanks everybody for joining us today, and thank you, Anita. It was a pleasure. Really enjoyed your presentation, and so glad that you could join us in sharing this.
Thank you.
Thanks, Anita.
Thank you. Have a wonderful day.
Yeah, thanks so much. Bye. Bye, everybody. Thanks so much.